Hello students, today we are going to study chapter number 13, electric current and its effects. Electric current and electric circuit. We know that electricity is a form of energy that is produced by the flow of charges through an electric conductor. This flow of electric charge is called electric current. The charge is carried by moving electrons in the electric circuit. The SI unit of electric current is ampere and the SI unit of electric charge is coulomb. Electric circuit. The conventional flow of electric current is from the positive terminal to the negative terminal of the cell or battery through a wire. This path followed by electric charges is called an electric circuit. In other words, we can say that it is the way the electricity moves in a defined path. Components of an electric circuit. An electric circuit has different components which have specific functions. A source of electricity, which can be an electric cell or a battery, is one of the important components of a circuit. A cell has two terminals, positive and negative. When a cell is connected to a circuit, the current flows from the positive terminal to the negative terminal of the cell and completes a circuit. A combination of two or more cells is called a battery. A wire. A wire is generally made of conducting material such as copper. Wire is made mostly of the metals that offer little or no resistance to the flowing electric current. Copper is said to offer minimum resistance to the flowing current, hence it is the most common metal of which wires are made. A switch is connected in a circuit that is used to make up or break a circuit. When the switch is in on position, current in a circuit flows and it completes the circuit. When the circuit is complete and current flows through it, it is called a closed circuit. When the switch is off position, the circuit breaks and the current stops flowing through it. This is called an open circuit. Now our next topic is heating effect of electric current. When current flows through an electric circuit, it produces heat. During the process, the electric current is converted into heat energy. In this process, when the electric current flows through the conducting wire, the temperature of the wire increases and it becomes hot. This is called heating effect of electric current. There are a number of appliances such as electric kettle, electric iron, and electric heater that work on the principle of heating effect of electric current. These appliances consist of an electric coil, which is called an element. When the current flows through this element, it becomes hot and gives out heat. The amount of heat produced depends on the kind of material of which the element is made, its length and thickness, and amount of current flow. The electric bulb is a good example of the flow and heating effect of electric current. The filament of a bulb is made of tungsten. As the current flows through the filament offers high resistance that makes it glow and produce heat. Tungsten has a very high melting point, and that is why it is used in electric bulbs. Apart from this, there is argon, an inert gas filled inside the bulb. Argon prevents the filament from catching fire. Now the next topic is electric fuse. When a large amount of electric current flows through an electric circuit, the wires often get overheated, which may lead to fire. An electric fuse is a safety device used in electric circuits that protects electric appliances from catching the fire when overheated. An electric fuse is usually made of an alloy of tin and lead that allows only a certain amount of current to pass through. As and when the amount of current passing through the wire increases, the wire melts down and breaks the circuit. This way, the devices in which the electric fuse was fitted and prevented from any damage. Electric fuses come in many sizes depending upon their uses. Cartridge fuse is mostly seen fitted in the electrical appliances that we use at home. Miniature circuit breakers (MCBs) are made of porcelain socket consisting of bimetallic strip. MCBs contain a switch that automatically trips when the amount of current flowing through a circuit exceeds, thereby preventing short circuits. Now we will know about the magnetic effects of electric current. When electric current flows through a wire, the wire starts acting like a magnet. This is called the magnetic effect of electric current. The magnetic effect of electric current was discovered by a famous physicist named Hans Christian Ørsted. He realized that a magnetic field was created around the current carrying wire in the circuit. He was the first to show that electric current also produces magnetic effect. To record this, he kept a magnetic compass near a current carrying conductor. It was observed that the magnetic compass showed deflection when the current passed through the conductor. Electromagnet. When electric current flows through a wire tied around an iron rod or nail, the iron rod behaves like a magnet. This magnetic effect of electric current has been used in making powerful electromagnets. The iron rod around which the wire is wound is called a solenoid. When the wire is wrapped around the iron rod many times and electric current is supplied to the wire, the iron rod behaves like a magnet as long as the current is supplied. The more the number of the turn in the wire, the stronger is the magnetic effect. Electromagnet is used in electric bells and also help in powerful cranes. The next topic of our this chapter is electric bell. An electric bell has electromagnet in it. It is made up of two rods of cast iron. The iron rods have a coil wrapped around them. The coil acts as an electromagnet. A metallic strip is placed parallel to the coils. This strip has a hammer connected to it at one end. The other part of the strip is connected with the circuit. A gong is placed in a position so that it can be hit by the hammer. When current flows in the circuit, the cast iron rod becomes charged with electromagnetic energy and attracts the metallic strip. As a result, the metallic hammer hits the gong. The circuit breaks when the metallic strip is pulled towards the electromagnet and gets disconnected from the point. Since there is no magnetism left in the electromagnet, the spring pulls back the metallic strip. This cycle is repeated again and again in the electric bell, which produces a ringing sound. That is why it is called a make break circuit. Thank you.